June 24, 1942, 0340 hours. The Coral Sea, 200 miles northeast of Australia. Commander Tyrrell Jacobs has been underwater for 6 hours. His boat, USS Sea Lion, is running silent at periscope depth. Ahead of him, a Japanese freighter sits low in the water, fully loaded, moving at 9 knots on a straight course. No evasive action, no escort, a perfect target. Jacobs fires. The torpedo runs true. The geometry is clean. His fire control party has checked the solution 3 times. At the calculated intercept point, the torpedo reaches the ship's hull. Nothing happens. He fires again. Same solution, same result. Nothing. He fires a 3rd time. Nothing. Jacobs stands at his periscope and watches a ship that should be on the bottom continue sailing northeast until it disappears over the horizon. Then he picks up his log and writes the sentence that will define the next 18 months of the Pacific Submarine War. 13 torpedoes fired, 13 failures to detonate, crew performance nominal, weapon performance inexplicable. He was not the first man to write that sentence. He would not be the last. And the institution responsible for the weapon he had just fired 13 times into a ship that sailed away untouched would spend the next 1.5 years telling men like Tyrrell Jacobs that the problem was them. This is the story of the most consequential institutional failure in the history of American naval warfare. A weapon that cost $10,000 per unit in 1940s money. A weapon that the United States Navy's Bureau of Ordnance certified as combat ready without ever firing a single live warhead at an actual target. A weapon with 4 separate and independently catastrophic defects that Buord's engineers knew about or should have known about and chose to explain away as crew error rather than admit they had sent American submarines to war with weapons that did not work. Before this story is over, you will understand why American submarines in 1942 and early 1943 achieved kill rates so far below their potential that senior commanders privately questioned whether the entire Pacific submarine program was worth its cost. You will understand why Japanese ships that should have been on the bottom kept sailing, why Japanese convoy routes that should have been severed kept delivering oil and ammunition and troops to island garrisons that American ground forces were bleeding to take, why men who executed textbook attacks came home with full torpedo tubes and empty victory pennants and were told by officers in offices in Washington that they simply needed more training. And you will understand how a small group of submarine commanders risking courts-martials, careers, and the institutional fury of one of the most entrenched bureaucracies in the United States military proved the truth through tests that were never officially authorized and forced an admission that Buord resisted until the evidence became impossible to deny. Here is the number that defines everything that follows. Between December 1941 and the end of 1943, American submarines fired approximately 4,000 Mark 14 torpedoes at confirmed Japanese targets. Conservative post-war analysis suggests that between 50 and 80% of those weapons either missed due to depth errors, detonated prematurely, failed to detonate on contact, or, in the most terrifying failure mode of all, circled back and attempted to sink the submarine that fired them. 50 to 80%. In a campaign where every torpedo represented weeks of patrol, where every missed ship represented oil and supplies and troops reaching Japanese garrisons that American ground forces were bleeding to take, where every failed attack meant an American submarine crew now being hunted by the escorts of a ship that should be sinking. The cost of those failures was not measured only in missed opportunities. It was measured in the crews who spent hours underwater absorbing depth charges from escorts alerted by the surface explosion of a premature detonation that told every Japanese ship within 5 miles exactly where the submarine was.
It was measured in the men who never came home from patrols where their weapons failed them at the moment of commitment. It was measured in the Japanese industrial capacity that kept running for 18 months longer than it should have because the weapon designed to strangle it had been sent to war broken. But to understand how this happened, you need to understand what the Mark 14 was supposed to be and why the institution that built it was so completely incapable of admitting what it had done. The Mark 14 steam torpedo entered development in the early 1930s. The United States Navy Bureau of Ordnance was responsible for its design, testing, and certification. BUORD was not staffed by careless men. Its engineers were credentialed professionals operating within a system that had produced functional naval weapons for decades. The problem was not competence in isolation. The problem was the system those competent men were operating inside. The Great Depression had compressed the Navy's testing budget to a fraction of what serious weapons development required. Live warhead firings against real targets were expensive. Each test torpedo that detonated uselessly against a test barge was a torpedo that cost $10,000 and produced nothing that could be shown to a congressional budget committee. So BUORD's testing protocols were built around economy. They tested torpedo running depth using exercise heads, dummy warheads filled with water ballast to simulate the weight of an actual explosive payload. They tested the magnetic exploder mechanism in the waters off Newport, Rhode Island, at latitudes where the Earth's magnetic field behaved in a specific and consistent way. They tested the contact exploder firing pin on static mounts, firing it into steel plates at angles that represented a clean perpendicular hit. What they did not do was fire a fully assembled Mark 14 with a live warhead at an actual ship hull under actual combat conditions. Not once. The decision not to conduct live warhead testing was not an oversight. It was a documented budget choice. The reasoning was preserved in BUORD's own internal correspondence. Live warhead tests destroyed the test weapon. Live warhead tests required target vessels. Live warhead tests cost money that the Depression-era Navy did not have, and that peacetime congressional budget committees were not prepared to approve for weapons that might never be needed. The reasoning was logical within its constraints. It was also catastrophically wrong. And the men who would pay for that decision were not the engineers at BUORD, they were the submarine crews in the Pacific. The first complaints reached BUORD within weeks of Pearl Harbor. Commander Elliot Lakeford of USS Gudgeon filed a patrol report in January 1942 describing 3 separate attack approaches on confirmed Japanese targets in which his torpedoes had run under the hulls without detonating. His fire control solutions had been checked. His crew's performance had been nominal. The weapons had simply passed beneath the targets they were aimed at. BUORD's response was formal, measured, and complete in its dismissal. The Mark 14 had been tested to specifications. Running depth had been verified through an extensive development program. If Commander Lakeford's torpedoes were running under their targets, the most probable explanation was error in depth setting or targeting procedure. The Bureau recommended additional crew training. Lakeford read the response and filed it. He was a professional officer inside a professional institution. The institution had spoken. He went back to sea with the same torpedoes and the same results. He was not alone. Throughout 1942, patrol reports from the Pacific submarine fleet accumulated a body of evidence that should have been impossible to explain away. USS Nautilus reported a point-blank attack on a Japanese destroyer. 2 torpedoes fired from less than 800 yards, both hitting the hull, neither detonating. USS Pompano reported an attack on a troop transport. 4 hits confirmed by the fire control party, no explosions. Commander Henry Munson of USS Crevalle documented an attack on a Japanese carrier in which 3 torpedoes struck the hull at the waterline and produced no result at all. 3 torpedoes against a carrier at waterline contact, nothing. Each of these reports went to BUORD. Each of them received a variation of the same response. The Mark 14 had been tested to specifications. The problem was most likely crew error. Additional training was recommended. The men writing these patrol reports were not junior officers making excuses for poor performance. They were experienced submarine commanders with records of technical proficiency and sound tactical judgment. They were telling the most powerful naval ordnance bureaucracy in the United States military that their weapons were not working, and the bureaucracy was telling them they were wrong.
Here's the psychology that made Buord's position possible and why it held for as long as it did. The Mark 14 had been developed over more than a decade. It represented an enormous investment of institutional time, professional credibility, and Depression-era budget allocation. The engineers who designed it had built their careers around it. The admirals who certified it had signed their names to documents stating it was ready for combat. The entire pre-war procurement process that had put this weapon in the hands of submarine crews depended on the assumption that Buord's testing and certification procedures were sound. Admitting that the Mark 14 was defective did not just mean admitting that one weapon had problems. It meant admitting that the testing procedures were inadequate, that the budget choices that eliminated live warhead testing had been wrong, that the men who had signed off on the weapon's combat readiness had certified something they had not actually verified, that the crews filing patrol reports from the Pacific were right and the institutional consensus was wrong. That admission carried professional consequences that the individuals inside Buord were not prepared to accept. So instead of investigating the complaints, they explained them away. Instead of testing the weapons against the evidence the patrol reports were presenting, they defended the weapons against the men reporting the evidence. It was not a conspiracy. It was something more ordinary and more dangerous. It was an institution protecting itself from information that threatened its self-image. And it kept happening, while Japanese ships kept sailing and American submarines kept coming home with the same story. The first man to test the Mark 14 outside official channels was not a submarine commander. He was a frustrated vice admiral who had run out of patience with official channels entirely. Vice Admiral Wilkin Cartwright, commander submarines Pacific in 1942, had been receiving the same patrol reports that Buord was dismissing. He had also been receiving the pressure from Pacific Fleet Command to demonstrate results. His submarines were not demonstrating results. His submarines were executing technically sound attacks on confirmed targets and coming home with nothing to show for it except fuel consumption reports and depth charge damage. In the summer of 1942, Cartwright authorized what Buord would later characterize as an unauthorized and scientifically unsound field test. He directed a team from his staff to fire 3 Mark 14 torpedoes set at specific depths toward a stretch of beach in a controlled location. The purpose was simple. He wanted to see where the weapons actually ran. The results were not subtle. All 3 torpedoes ran deep, not slightly deep, not marginally below their set depth. They ran between 9 and 11 feet deeper than the depth settings indicated. The weapons that Buord had certified ran at set depth were routinely running at depths that would carry them under the hulls of most Japanese merchant vessels. Cartwright sent the results to Buord. Buord's response was that the test methodology was flawed, that beach firing did not replicate operational conditions, and that the results could not be considered valid evidence of a systematic depth-keeping problem. They maintained their position. The Mark 14 ran at set depth. The problem was crew error. Cartwright was furious. He was also a flag officer inside a chain of command that ran through Buord's parent organization, and direct confrontation carried consequences he was not yet positioned to force. He filed his test results. He documented his objections. He kept sending submarines to sea with the same weapons. The submarines kept coming home with the same reports. June 14, 1943, 02:14 hours, the Solomon Sea. Lieutenant Commander Daspit has just fired a spread of Mark 14 torpedoes at a confirmed Japanese tanker. His fire control solution is clean. His crew is at battle stations. His sonar operator is tracking the weapon runs. Then, the sonar operator says something that makes every man in the control room go still. "Captain, I have a torpedo, bearing 270, speed approximately 46 knots. It's turning." Daspit looks at the plot. The bearing is not toward the target. The bearing is toward USS Tenosa. He has 9 seconds. "All ahead flank, hard right rudder, dive, dive, dive!" The torpedo misses by approximately 300 feet. Daspit comes to periscope depth. The tanker is still afloat. One of his own weapons just tried to kill him. He picks up his log and begins writing a report that he already knows Buward will dismiss, because at this point in the Pacific Submarine War, every man wearing dolphins has accepted a truth that the institution ashore refuses to acknowledge. The weapon is broken. The institution knows it, and nobody with the authority to force the fix has yet been willing to pay the professional price of forcing it. That is about to change. The circular run failure was not a rare anomaly. Post-war analysis of Pacific submarine patrol reports identified at least 22 confirmed or probable circular run incidents before the end of 1943. In most cases, the returning torpedo missed the firing submarine. In several cases, it did not. The gyroscope that controlled the Mark 14's directional stability had a failure mode that Buward's pacetime testing had not detected, because Buward's pacetime testing had not fired enough weapons under enough varied conditions to establish a statistical baseline for failure rates. When the gyro failed in a specific way, the torpedo's rudder deflected to its maximum position and held there. The weapon ran in a circle of approximately 800 yards diameter at 46 knots. The submarine that fired it was typically within that circle. The men who survived circular runs did not receive acknowledgement from Buward that the failure mode was real. They received the standard response. The testing data did not support the existence of a systematic gyro failure. Crew error in torpedo tube preparation was the most probable explanation. Additional training was recommended. By mid-1943, the phrase "additional training was recommended" had become something that Pacific submarine commanders said to each other with a bitterness that required no further explanation.
Charles Lockwood arrived as Commander Submarines Pacific in February 1943 with a reputation that preceded him in ways that made Buward's Washington offices quietly uncomfortable. Lockwood was not a diplomat. He was not a man who processed institutional resistance with patience and professional deference. He was a submarine officer who had spent the early months of the war watching his boats produce results that did not match the quality of the men and the soundness of the tactics he could see in their patrol reports. And he had read enough of those patrol reports to have formed a conclusion that he stated in his first week in command with a directness that his staff found either inspiring or alarming, depending on their position in the chain of command. "The torpedo does not work. We are going to prove it does not work, and then we are going to fix it." The test he authorized in March 1943 off the coast of Western Australia was not subtle. It was not designed to be subtle. Lockwood wanted numbers that were impossible to argue with, gathered under conditions that Buward could not dismiss as flawed methodology. He suspended a large cargo net vertically in the water at a measured depth. He fired 3 Mark 14 torpedoes set to run at 10 feet, a depth that should have put them squarely in the center of the net. The torpedoes would either cut the net at 10 feet, confirming the depth setting, or they would cut it somewhere else, confirming what every submarine commander in his fleet had been reporting for 18 months. The net showed cuts at 21 feet, not 11 feet, not 12 feet, 21 feet. Torpedoes set to run at 10 feet were running at 21 feet, a depth at which they would pass completely under the hull of every Japanese destroyer, most Japanese cruisers, and a significant percentage of Japanese merchant vessels. Lockwood put the net measurements in a formal report and sent it directly to Admiral Ernest King, Commander-in-Chief, United States Fleet, bypassing the normal routing through Buward.
This was not an accident. Lockwood understood exactly what he was doing. He was not filing a complaint through channels that had already proven they would produce no result. He was putting documented evidence in front of the one man in the American naval command structure with sufficient authority to force Buord to respond, regardless of what Buord's own institutional interest demanded. King read the report. King forwarded it to Buord with a request for a formal response that, given its source and its tone, was not actually a request. Buord's formal response acknowledged that the Australian net tests had produced results inconsistent with the Mark 14's certified depth-keeping performance. They attributed the discrepancy to differences between test conditions and operational conditions. They stated that the matter would be investigated.
Lockwood wrote back the same day. The matter had been investigated by him with a net and a ruler. The results were enclosed. He requested a timeline for the depth-keeping fix. The depth-keeping problem turned out to have two causes, and the fix for each of them was straightforward to the point of embarrassment. The first cause was a design flaw in the depth control mechanism. A small valve that regulated the hydrostatic pressure reference for the depth-keeping system was incorrectly calibrated. The calibration error had been introduced during development and had never been caught because the exercise heads used in pre-war testing were slightly lighter than live warheads, and the weight difference had masked the valve's behavior at actual combat weight. The fix required adjusting the valve, one component already installed in every torpedo, adjustable with standard tools in approximately 40 minutes. The second cause was the testing methodology itself. Buord had verified depth-keeping performance using exercise heads because live warhead tests were too expensive. The exercise heads were not the same weight as live warheads. The test results were not valid for combat-configured weapons. This had been true for the entire development program. Nobody had checked. When Lockwood's engineering staff presented these findings to Buord's technical division, the response from the engineers who reviewed it was recorded in an internal memorandum that survived the war. The memorandum noted that the depth-keeping discrepancy was consistent with the known weight differential between exercise and live warhead configurations, and that the calibration error in the depth valve was consistent with a systematic testing oversight. It recommended immediate recalibration of all Mark 14 depth control mechanisms across the fleet. It did not address why this had not been discovered during the weapon's development. It did not address why the patrol reports filed throughout 1942 had not prompted an investigation that would have reached this conclusion 18 months earlier. It addressed only the fix and its implementation timeline. The depth valve was recalibrated across the Pacific submarine fleet by June 1943, but the depth-keeping fix revealed the second problem, because when submarines began firing at the correct depth and their torpedoes began reaching their targets, the targets did not sink. The weapons were running at the right depth, they were hitting the hulls, and then nothing was happening. The depth fix had removed one layer of the failure. Underneath it was something worse. The magnetic exploder problem was in some ways the most technically sophisticated of the Mark 14's defects, and in some ways the most damning indictment of Buord's testing methodology. The Mark 6 exploder, fitted to the Mark 14 as its primary detonation mechanism, was designed to work on a principle of elegant simplicity. A steel ship hull moving through water generates a local distortion in the Earth's magnetic field. The Mark 6 was designed to detect that distortion and trigger the warhead at the moment of closest approach to the hull. A perfect underbelly detonation without requiring direct contact. The physics were sound. The problem was geography. Buord had developed and tested the Mark 6 in the waters off Newport, Rhode Island. Newport sits at approximately 41 degrees north latitude. The Earth's magnetic field at 41 degrees north has a specific intensity and a specific angle of inclination. The Mark 6's sensitivity settings had been calibrated for those specific values.
The Pacific War was fought primarily between the Tropic of Cancer and the Tropic of Capricorn. In equatorial and near-equatorial waters, the Earth's magnetic field has different intensity and different inclination characteristics than it does off Newport, Rhode Island. The Mark VI had never been tested at those latitudes. What happened when a Mark VI calibrated for Newport's magnetic field encountered a ship hull in the equatorial Pacific was not a clean underbelly detonation. What happened was a premature. The exploder triggered before the torpedo reached the hull, sometimes 50 yards before, sometimes 100 yards before. The explosion was real, but it was in open water, and the ship sailed through it unharmed. Worse, the explosion announced the attack. Every Japanese ship within visual range knew an American submarine had just fired a torpedo. Every escort within sonar range began prosecuting the attack position. The submarine that had just spent hours developing its firing solution was now the hunted rather than the hunter. And Buward's explanation for premature detonations in patrol reports had been consistent. Crew error in exploder maintenance. Additional training recommended. The deactivation of the magnetic exploder was Lockwood's second battle with Buward, and in some ways the more revealing one, because unlike the depth-keeping problem, which required testing and calculation to diagnose, the magnetic exploder problem had been reported clearly and specifically in patrol reports for more than a year. Commanders had described premature detonations. They had described the explosions occurring ahead of the target. They had correlated the premature rate with proximity to the equator and noted that attacks in higher latitude waters produced fewer prematures than tropical waters. The correlation between latitude and premature rate was in the patrol reports. It was documented evidence of exactly the geographic sensitivity problem that Buward's Newport-based testing could not have detected. Any analyst reviewing the patrol reports with an open mind would have identified it. Buward's analysts had reviewed the patrol reports. Their conclusion was that the premature rate reflected improper exploder maintenance by the crews. The latitude correlation was not mentioned in any of their formal responses. Lockwood ordered the deactivation of the magnetic feature of the Mark XIV exploder across his command in June 1943. He did not request Buward's permission. He informed them after the fact. Buward's formal protest noted that deactivating the magnetic feature eliminated the primary detonation mechanism and reduced the Mark XIV to a contact-only weapon. They recommended against the change. Lockwood implemented it anyway. His submarines now had torpedoes running at the correct depth with a deactivated magnetic exploder that had been causing prematures for 2 years. The premature rate dropped immediately, and the contact exploder became the only detonation mechanism remaining, which was when the third and most maddening problem revealed itself. The contact exploder did not work either. Commander Daspit of USS Tinosa had survived his circular run in June. In July, he found himself in what submarine commanders called a dream attack position, a large Japanese whale factory ship converted to a naval tanker, the Tonen Maru, sitting in the water like a building, moving at 8 knots on a straight course with no escort in sight. Daspit fired 15 torpedoes. He heard and observed 15 impacts, 15 hits on a stationary target at close range with textbook solutions and correct depth settings. 15 times the warhead reached the hull of the target ship at the designed contact point. The Tonen Maru sailed away. Daspit did something that was either an act of extraordinary professional discipline or a measure of how completely the Pacific Submarine Force had been driven to improvisation by 18 months of institutional failure. He saved 1 torpedo. He brought it home to Pearl Harbor in his torpedo tubes, undamaged, unfired, with its contact exploder intact. He walked into Lockwood's office and put the technical request on his desk. He did not file a complaint. He did not write a patrol report. He said 4 words: "Find out what's wrong." Lockwood's torpedo technicians disassembled the contact exploder and found the answer in 45 minutes. The Mark VI contact exploder's firing pin was too heavy, combined with a guiding mechanism that was too brittle. When the torpedo struck a ship hull at a perpendicular angle, the impact decelerated the warhead so rapidly that the firing pin, instead of driving forward into the primer, was crushed against its own guide rails before it could complete its travel. The harder the hit, the faster the deceleration, the more certain the dud. A glancing hit at an oblique angle had a better chance of detonating than a direct perpendicular impact. The weapon was most likely to fail when it hit exactly where it was aimed. The fix required replacing the firing pin with a lighter version machined from a stronger alloy. The solution came not from Buord's engineering division, but from a machinist at the Newport Torpedo Station named Guy Savvy, who had been looking at the problem on his own time after reading a maintenance bulletin that did not explain why the pin was failing, only that it sometimes did. Savvy's redesigned pin was tested at Pearl Harbor in September 1943. Lockwood's team dropped Mark 14 warheads from a crane onto a steel plate to simulate contact impact. The original pin failed 11 of 12 times. Savvy's pin detonated 10 of 12 times. The new pin went into production. By late 1943, the Mark 14 torpedo had a reliable depth-keeping mechanism, a deactivated magnetic exploder, and a contact exploder firing pin that actually fired. The weapon that American submarines had been taking to sea since December 1941 finally worked. The question that the patrol reports of 1944 answer with terrible clarity is what the Pacific submarine campaign might have been if the Mark 14 had worked from the beginning. In the 18 months between Pearl Harbor and the end of 1943, American submarines fired approximately 4,000 defective torpedoes. The conservative estimate of the Japanese shipping that survived due to weapon failure rather than tactical error is between 400,000 and 500,000 tons. Shipping that continued delivering oil, troops, and ammunition to Japanese positions throughout the Pacific during the period when American ground forces were paying in blood for islands that Japanese logistics were keeping supplied. In 1944, with functional torpedoes, American submarines sank more Japanese shipping in 12 months than they had sunk in the previous 2 years combined. The mathematics of that comparison are not abstract. They are measured in the Marines who died on beaches that Japanese garrisons would not have been able to defend without the supply lines that defective torpedoes had allowed to keep running. Measured in the aviators lost over targets that would have been undefended earlier if Japanese fuel imports had been cut on the timeline that a functional submarine campaign would have produced. They are measured in the months by which the war continued past the point at which Japan's logistical position had become genuinely untenable. Buord never formally acknowledged that the defects in the Mark 14 had been present and documentable from the beginning of the war. Their post-war assessment characterized the torpedo problems as developmental issues that had been identified and resolved through the normal process of operational feedback and engineering response. The patrol reports that had been dismissed as crew error were not mentioned. The unauthorized tests that had produced the evidence Buord could not answer were described as informal investigations. The officers who had defied institutional pressure to force the fixes were commended in general terms. Charles Lockwood retired as a vice admiral in 1947. He wrote a memoir. He named names. He was precise about dates and documents and the specific sequence of events through which the fixes had been forced over institutional resistance. His account was not disputed by anyone with first-hand knowledge because the first-hand knowledge confirmed it. Tyrrell Jacobs, who who had fired 13 torpedoes at a ship that sailed away, completed the war with a record that his post-fix patrol results eventually justified. The 13 empty shots from June 1942 stayed in his record. Buord's explanation for them stayed in their files. The machinist who redesigned the firing pin retired without ceremony. His name appears in one document. The torpedo that Daspit brought home to Pearl Harbor, the torpedo that made the diagnosis possible, was disassembled for parts. Here is what the Mark 14 torpedo scandal actually tells us. Not about torpedoes, not about the Pacific War, about what happens when an institution is asked to evaluate evidence that threatens its own self-assessment. Buord was not staffed by cowards or fools. The engineers who designed the Mark 14 were technically qualified professionals. The admirals who certified it were experienced naval officers who believed they were sending a capable weapon to sea. The analysts who reviewed the patrol reports and concluded crew error were applying a standard institutional response to complaints that in peacetime might exactly be what they appeared to be. The failure was not individual, it was structural. The institution had no mechanism for processing evidence that contradicted its own testing data because the institution's testing data was the foundation of its professional identity. Admitting that the data was wrong meant admitting the identity was wrong. That admission was not available at any price that the institution could see clearly enough to choose. It took men who were willing to operate outside the institution's channels to force the evidence into a form that the institution could not dismiss. It took Lockwood sending his net measurements directly to King, rather than routing them through Buord. It took Daspit bringing an unfired torpedo home in his tubes, rather than filing another report that would receive the standard response. It took a machinist working on his own time because the official engineering review had not found the problem it was not looking for. The fixes were simple: a valve adjustment, a deactivated exploder, a lighter firing pin. None of them required new engineering, none of them required new materials, none of them required any capability American manufacturing did not have in December 1941. They required only the institutional willingness to admit that the testing was inadequate, that the complaints were valid, that the crews were right. That willingness took 2 years to produce, 2 years during which Japanese ships sailed through water where American submarines had fired at them and missed. 2 years during which the toll of those misses was paid not by the men who certified the weapon, but by the men who fired it. The submarine force recovered. In 1944 and 1945, American submarines accomplished what Lockwood had always known they were capable of, strangling Japan's logistics so completely that by the summer of 1945, Japanese warships were being rationed on sortie fuel, and Japanese factories were running at fractions of their capacity. The campaign that the Mark 14's defects had delayed by 2 years ultimately achieved everything its strategic architects had projected. The price of the delay was paid in full. The record that USS Archerfish set in November 1944, the largest warship ever sunk by a submarine, was set with Mark 14 torpedoes. The same weapon that had failed Tyrrell Jacobs 13 times in June 1942. The same weapon that had run under ship after ship for 18 months while Buord explained the failures as crew error. The 4 torpedoes that opened Shinano's hull worked because Lockwood and Daspit and Savvy and the commanders who brought their evidence to people who could not ignore it had refused to accept that the official answer was the correct answer. The largest warship in the history was sent to the bottom by a weapon that should have been working from the beginning. That is the Mark 14 torpedo scandal. Not just the story of a defective weapon, the story of what it costs when the people responsible for the truth decide that protecting themselves from it is more important than telling it. And somewhere in the files of the Bureau of Ordnance, the patrol reports that documented every one of those failures are still there, filed under crew error, additional training recommended. If this story stayed with you, subscribe. The next one goes deeper. The sea remembers what the institutions tried to forget.